So one of the things where I really came into play, where it's sort of a Lois, can we get away with this or not in the design scenario, because it is a very dynamic design process. You don't have to do certain things. You come up with a package that works, right? So the windows, what we were looking at, how many feet above do we have to go to metal or fiberglass? Is it over 8 feet in New York, where you have to go to a 8 stories? So obviously the building's tall, we can't use vinyl. We didn't want to use vinyl, architect would not want to use vinyl. But so we're stuck with sort of the aluminum stock that's out there. And you don't have a lot of good choices for thermally broken, really good thermally broken metal windows. So that was one of the issues. The other issue is that you need to get, for Passive House, for us to do our proper analysis, we need to get European analysis done on the windows. We need values for the U value of the frame, the center of the glass, and the glass edge around the frame. We need those all separated out. And if you're using an American manufacturer, man, is this a fight. So just be prepared for that. We need them because we need to analyze condensation potential in particular. And so you need to make sure that the coldest spot on that window is not going to be colder than a certain temperature. For us, it was 49 degrees when you're under design conditions outside in the winter. Okay, so we really had to, fight through some of our window issues to come up with our proper U values for the assembly. So you can see each of the nodes, they calculate the U value of the frame in each of those, and then you come up with an overall U value for your window. For our climate, for comfort, so Passive House is not just interested in energy. It's very, very focused on comfort and durability of the building. So the condensation I already mentioned, there's also a comfort criteria where they don't want the surfaces to be more than about 8 degrees colder, 8 degrees colder than the temperature in the space, okay? So that leaves us with somewhere around a 58-degree temperature on our surfaces, on the exterior surfaces. So for our climate, about 0.20 was the U value for the window that we needed to achieve. That they didn't want us to have anything worse than that because the occupants would feel too much cold coming from their windows. All right, so you do have to pay attention to comfort, even though it's a very flexible system. One thing to know is that if your window manufacturer is giving you a hard time, please know there are third-party analysts that can do the analysis for you. It's not tens of thousands of dollars. I think the cost was less than one of our windows to have somebody do it on a fire-rated window for us. So it's out there. If you're frustrated and you need, Lois, who can I call? Just throw me a line and I can give you some contact information if you're fighting with this on your projects. And then we have a very interesting analysis that Luke would like to tell you about.
Yeah, so if you find yourself talking to an American window manufacturer and they can't supply you with the windows that Passive House wants, you just need to explain to them that it's like the McDLT, which was sort of America's first foray into thermal breaks, right? You keep the hot side hot and the cold side cold. All right, I thought that was brilliant. So you got to work with me here a little bit.
He forced us to put it in the presentation. I was like, on my slide, I have the McDonald's on my slide. So this is basically, after they do that analysis, this is basically what you wind up with. This is our U values of the frames for each of the different typical windows that we have. So this is our target so that we would meet our condensation potential at the frame. And then this was our target for comfort reasons. And you can see the average for the overall window is very good. So even though it's an aluminum window, it's an excellent, excellent window. So this is one of the places where the Passive House consultant is the biggest pain in the butt. And if your Passive House consultant is not a pain in the butt, you either have done this before or you need to talk to them because this was a massive amount of work. In a building like this, in any building, you need to come up with an air barrier set. And you need to do it because you need to identify every single place where materials change, right? Where you go from a window to a wall, from the wall to the roof, every corner, every place you change in insulation types, everything, because that air barrier must be continuous. And also the insulation must be continuous. So my first pass was to draw the line around the building in section and plans. You pull out where every single one of those connections is. You go searching through the plans to find the detail, and then you evaluate that detail. Is everything continuous? Is my vapor barrier continuous? Is my air barrier continuous? One of the interesting things about a panelized system like this is it doesn't get air sealed until the building's almost pretty well enclosed. By that time, once it's enclosed, they're starting sheetrocking on the bottom floor, right? They're going. This type of building, they don't wait for you. So I can't wait till they caulk that entire building to test for air leakage. That was the panel manufacturer's air barrier, was the caulk on the outside. So from the very beginning, I was like, nope, 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 can't do it. You gotta do inside, gotta make it inside, gotta make it inside, gotta tape, everything's gotta be taped inside. And they were like, well, we have caulk. Nope, can't do it. So I was a real pain in the neck about this. But we worked into it because I have to test along the way. I have to be able to tell them whether they're doing good or bad, right? So we can't wait to the end. After this beautiful, long process, everybody's on board to do it. And then I failed to show them where they were failing during construction. It's not possible.
So what I want to say about that detail, don't take a picture of it, because
This was our
it's
first.
really not it's not a complete detail yet. What we're trying to show you here with the bubbles and the different colors of lines is this is the contractor, the architect, the Vidaris was our exterior wall consultant, as well as Lois. This is all of us marking up, working, trying. This is a very particular condition at the base of our building. It only happens once. And so it's just one condition where we want to explain this iterative and process that has just been much more elevated than any other job that I've worked on. And it's a good thing, but it's been, we just wanted to show you a bit of the process here of trying to work with these conditions.
And then the construction managers come in and say, nope, we want to do this, we're not going to do this, we don't want to do this, okay, this is good, we'll use that, so they also have a say in the process as well.
Yeah, they've marked up the drawings quite a lot. Why do you need this piece of tape?
Yeah, so that was great.
You can start with the vapor
Okay,
barrier.
so the air barrier that we wound up putting in was a vapor barrier, air barrier, sort of all in one. Originally, there had been a FSK foil face assumed for the interior vapor barrier. But then there was some question about whether that could get installed in the shop because it would get damaged on the way to the field, the continuity of it, the tapes that they were going to use. They didn't want to tape to the window because it was a foil tape and it was really hard to use. So we really worked with them, with the construction managers and with Eastern, to show them different products that would be flexible and that would be more user-friendly. And what we wound up coming up with was a vapor retarder, a smart vapor retarder that will get installed on the inside. It'll get taped around all the windows. You're not going to see this many seams because one sheet will cover an entire panel, so we're only going to have seams where the panels connect. So it's going to be a much cleaner, much more airtight barrier than it sort of looks like here.
And what's amazing about this slide is to see this. This happened very late in our process. This was maybe 2 months ago. And that's very far into the development of the drawings. We've been pushing the contractor, pushing Eastern, and testing. And so, you can't give up. You have to keep pushing for these products to be integrated because they've never seen these products. They don't want to use them. They don't know how much they cost. Where do they get them? Lead times. But you just need to keep working to get these products integrated because ultimately this is going to save them time. It's not going to be damaged. It has less joints. And it's actually... They now are happy to be using it. But the process of getting there is, an iterative learning process for everybody.
Yeah.
So we were very excited about this moment in our project.
Yeah, that's true. So this just shows the detail here. So the double line of caulk, so this is the outside here. This is the double line of caulk, which is their air barrier, the Eastern's original air barrier. And so the vapor barrier is on the interior, and that's continuous. And so I can test that. I can test the seams. I can test the windows now, and with some level of confidence that it's going to make it. And when we did the mock-up, it actually tested 2 Passive House recommended levels of 0.03 CFM per square foot. So it was, very good.
And so something that's really cool also in this detail is this little thermal break. This is a really important moment also for the project because this piece of metal would have brought in...
I think you have to speak into your mic.
Oh, I'm sorry. So another really important thing for our project is this thermal break, which is developed for our project. This piece of metal that is integral in supporting the exterior wall is now broken, and so that the warm air will not be traveling through. It will eliminate a thermal bridge, and that was a real problem. That thermal bridge was a real problem for our project, and Eastern did develop with us integrating that thermal break. So that was another great moment. So this is our typical window detail here. We're utilizing a Schuko window that is thermally broken. You're seeing it here in plan. This is the inside. This is the outside. All of these delicious thermal breaks here are separating metal to metal. We're utilizing triple glazing throughout the job. Thank you, owner, for the triple glazing. And we have warm edge spacers, which have a huge effect on the performance of the glass, introducing the warm edge spacers. And we're using a European warm edge spacer that we've gone through many submittals to make sure that this spacer is compliant with what Vidaris wants to see. So that also it helps the performance tremendously. A typical window is 0.45, and we're at 0.18. So we're really making a much better U value here. Here's our double line of caulk, and what's interesting also about this detail is this line of tape, which was, again, this is all in the shop, right? This detail is all executed in the shop. We had a big battle because the caulk takes 28 days to cure, and they can't put on this piece of tape because it will inhibit the caulk from curing, and the panel will already be stored during those 28 days. They don't want to then take out the panel to put on the piece of tape. That doesn't work for their sequencing. It would have been not feasible. So we worked with Dow Chemical. We did a lot of testing to make sure that this tape was breathable enough and put on at the right time that the caulk would still be able to cure. So they will be able to put on this piece of tape in the right sequence. And that, was just great, right?
Yeah,
all
this
these little
pain in the ass consultant. No, you need to tape around the windows. You need to tape around the windows. No, you have to tape around the windows.
And so I guess we'll maybe get a little quicker here. This is a typical condition for us. This is the anchor condition where the facade is held on to the building with anchors. This condition happens 3,000 times in our building. It has caused Lois tremendous pain and strife. This detail shows how, this picture here shows how the anchor will invade into the thermal barrier of the project, and figuring out how this condition will be both insulated and then taped over 3,000 times has been very, very interesting process, and one that also was very recently figured out through the mock-up. The mock-up has been incredibly helpful for us here.
Yeah, I think that's one thing that you need to realize. There's some things you're just not going to figure out in the design studio. We were sitting at a table for the 100th time looking at this anchor with the panel manufacturer, with the construction crew, me, the owners, everybody going, what are we going to do? And finally, Eastern just said to us, we're just going to have to figure it out in mock-up. And we all just shut up and said, okay, we'll figure it out at the mock-up, and we did.
And so this drawing, we call this the miracle drawing. Actually, I was in Israel when I received this drawing on my phone, and I really did feel as though it was divine intervention. This is done by Eastern Wall Panel, and this drawing is showing how the thermal barrier will arrive to the site with certain flaps and other pieces of tape already pre-installed in the shop, but flapping and ready to sit over the anchor and then seal over the anchor, so you will have a continuous seal. And actually getting the contractor to draw this drawing, to show the sort of flapping and flipping, and to show the steps as how, retain, release backing on remainder of tape until it is time to seal the membrane. I mean, amazing, right? And now this is out there for everyone to use, to know that you can have the contractor bring this flippity-floppity sort of thing to the site, and it will, I think this will work.
No, it will work.
It will work. And here is
It's going to work.
So here is a dismayed site super. I don't know if you can see his face clearly. He's holding some tape, and he's just sort of, for the first time, this guy is holding this tape and wondering how he's going to use it. And we actually had him stick some up in the corner of our site trailer, and they will go through some training sessions as well.
It was a great moment too, because it wasn't this construction manager, it was the higher up, and he's like, how am I going to tape that corner? Tell me how to tape that corner. I don't know how to tape that corner. And we had one of the representatives, Ken, he was there showing them different tapes, and he took a little snip, he snipped it, just when he made the corner of the tape, before he even put it up there, they went, oh! It was great.
It was really, and it's still on it's in the site trailer now.
trailer.
It's in the trailer. And these are some of the tapes that we're doing. This is interesting for maybe architects. We developed a tape schedule, the different types of tape, right? CMs love schedules, right? So put everything on a schedule, tape 1, tape 2, tape 3, and then you can easily key it into the drawings. Tape 1, tape 2 goes here, right? Gasket 1, gasket 2, right? So make it as clear as you can, put it on a schedule, and then this was very helpful for us to get it into the schedule. So here we're just showing you, there's a lot of trades that are affected by Passive House. I'm sure you guys know that, but the contractor didn't really know that, and we needed to clean up our specs. You need to really integrate it into the specs, make it clear for the contractor. They will not know this list, and when they're going through their buys, they need to, of course, have a clear scope of what's going on. And so as clear as you can try and make it for them, of course, the better. They will always say, they didn't buy that, you know, and so you're going to have to remind them it's on the drawings, or you're going to have to beg your owner to pay for it.
So this is just a slide showing you sort of the testing that will get done in the field, because when you're doing a passive house or when you're doing a high-rise like this, the sequencing of events and the number of people on the job does not allow you to say, okay, everyone go home for 4 or 5 hours. I'm going to tape off 3 floors. I'm going to do a blower door test today. They look at me like, what? You know, I can't even get them to move for 5 minutes. So what you need to do for these types of projects is you pick out your critical junctions and you actually mask them off. You make yourself a little mock-up chamber in the field and you smoke test them, right? You create a little, our colleague here, Terry, who is a consultant on our project to help us with the high-rise testing, is making a chamber out of the window. And then we install a little fan to create a little pressure and we insert smoke into that window chamber. And then we go to the other side and we look and see where the smoke's coming out. This is a beautifully tight window. The only place the smoke came out was actually the weep holes. Just a little tiny little hole came out the weep hole. So, but this is the type of testing that you'll have to do on site if you are a verifier, or that you'll have to schedule in. They don't actually have to do anything special for me when I get there. I just need power, and then they need to let me have one window for a while. And there's how many thousands of windows in this project. So this is the type of thing I need to know their schedule more than they need to get out of my way. That's what's more important about this. Yeah. And so the blower door test gets done at the end. For a large building like this, you actually need to create a blower door test plan because it's a slightly different procedure than a small building. So you need to actually tell the passive house the certifiers what you're going to do, what rooms are inside and outside the air barrier, where you're going to put your doors, your meters, and this follows really the Air Barrier Association's guidelines and testing for large buildings. So there's help for you out there so that you can include it in your specifications for your consultants if you need to do that.